Yeah.
Okay, we started. Okay, I think we're live.
And then we smile.
But we're not really live, right? This is just like we're just trying out stuff. So for everybody who's already here, this is not the official start of the stream. We're just like
It
testing out.
hasn't started for me. Now it's starting for me.
Oh yeah, yeah, it takes a while. I mean, I did choose like extremely low latency, but I think like that term is like kind of like what do you call
It's a
it?
liberal term.
They use it very liberally.
Yeah.
But you can see the feed now, can you?
Yeah.
Okay, let me try switching to like different views, right? So first the iPad. Tell me if and when you can see the iPad, please.
I could already.
Oh,
Second ago.
can you see me draw on the schematic? Does that work?
Yes. Now.
Very
Yeah.
nice, very nice, very nice. Okay, let me try something else. How about the breadboard? Do you see my
But
beautiful?
that's such a lovely drawing. Yeah. Now I see breadboard.
Great, great, great. Let's see the browser. Do you see the browser
Now.
now? Okay, good. What else do we have? We have the 808 manual. Do you see that one?
Yeah.
All right, I think it works. If anybody's already in the chat,
Do you see anything in chat?
so it tells me the resolution is not supported. What the fuck?
What?
Open the
What resolution are you going for?
Well, it says I'm using 2560 by 1440, and it says it's not supported.
May I ask why you go super high resolution?
I didn't select that. Okay, so someone. Okay, so yeah, so people say they cannot hear other guy. I'm guessing you is other guy, and they say my volume is really
Uh-huh.
low. So let me try. I anticipated that, no, didn't I? Let me try this. So maybe this is better. No.
One is far too quiet. No sound from me. Yeah. But I mean, you hear me, so it's on your end.
But oh, they say bottom guy is too quiet. That
You're the bottom
I'm
guy.
the bottom guy. I'm the
Yeah.
actually.
Oh yeah, because you haven't done official face reveal, right?
No. People don't know.
Oh yeah,
Who
yeah.
yeah.
So they thought I was you?
Maybe. I'm not sure.
That would be so cool. Oh, we should have planned that. We should have planned it to be face reveal, and then it's me. Oh, so Simon the Magpie is Moritz. Oh my god!
Yeah.
Yeah. Could have pranked a generation of DIY enthusiasts.
That would have been a great prank. Okay. So
You would
I'm
have would have lost so many Patreons if you would have done that.
Oh, I can go past 100% with a.
That's cool. 100% is just a suggestion.
But it doesn't change anything. Like it's still the same volume. This is so weird. Wait, let me try and switch this to a different input. So now I'm using my. Okay, now I'm using my laptop microphone. Let me switch to the interface. Okay, Simon, you still hear me, right?
Yes.
Okay, and it's using the correct microphone, but it's extremely low in volume. Why? Now better? No, it's the same.
It's the same.
Well, I can. Yeah. Now it's clipping. But in OBS, it's like really quiet. Why? I don't. Does maybe anyone in the chat knows it?
Can someone in chat please drive over to Moritz really quickly and solve this?
Fix my audio, yes, please. Oh God. But wait, maybe it has to do with the Video Ninja thing. Like maybe that's like set up incorrectly.
If you try switching microphone to just your computer microphone in video in that program, and I can deal with the roominess and the stream gets perhaps better quality. I don't know how shit works. I'm just saying words.
Yeah. Wait, let me. I will try something. So, boom. I will monitor myself. Oh, I'm not sending the thing. I think. Let me try it now.
They can hear me fine, which is too bad for you. I don't have a great, lovely. I can talk nice.
Well, maybe now it's better. Can someone tell me, like in the chat, can you hear me better now? John, since you're talking about the audio level right now, is maybe my level now higher? That would be fucking awesome.
For me, it's same thing, just so you know, so you never have to second guess that.
I mean, you hear me through Video Ninja, but I'm because there would be latency. I muted myself in that, and I'm just like sending myself like from OBS. But for whatever reason, it just doesn't want to.
Work, I guess.
Yes. Maybe
Look at us finishing each other's sentences already.
Yeah. This is so strange. And on my interface, it's already like completely turned up. So, and it's almost clipping, and it's not getting into OBS.
It's still very low. Yeah.
Yeah, I don't get it.
But if I whisper, everyone can they can up their volume on their computers.
Yeah, that's a great idea.
It's the ASMR Cowbell stream.
Yeah. It doesn't work. This is absolutely absurd.
You also don't have that. I have that, YouTube voice curse where as soon as I start recording a video, I start screaming, "Hi, I'm the Magpie!" Wow, 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 wow.
No, I don't do that. No.
Yeah.
Okay.
Would be kind of weird to do it for you with the breadboards.
Yeah.
Hyper excited. Maybe you can just copy your own audio over and over again. Oh, I am. I'm getting ready. I'm gonna be pretty for the stream. No, I think we're very excited for the do sign language. They're saying. I know a little bit of sign language from work, but not a lot. So, yeah. Thank you. Now I'm sort of calling myself. I don't think I can remember anything. Jeez. Like any other language, I think. Repetition.
Okay. I think I have to like restart OBS. Okay, so I think that's the last resort. Let me try that. I will restart OBS. I will restart my machine really quickly. I'm really sorry, everybody. It's going to take like 10 minutes later. We're going to be back then. Let's see.
There.
Say it again.
Analog is there.
Who's there? Oh, Analog is there. Oh, nice.
My only friend.
Okay, I think we're good. Can you yourself in the stream see everything? Can you check?
Good evening.
No, I don't mean in the chat. I mean like you can see us, right?
I can see us.
Right, and they say that they can hear both of us, which is amazing.
See and hear everything.
Yes.
That's a weird humble brag, Analog.
But yeah, I think it works now. I think this is good. I think we can start. All right. Sorry everybody for the delay. We had some technical difficulties, but we managed to fix them because that's what we're here for, actually. Yes. So first up, elephant in the room. Yes, I'm showing my face. I don't normally show my face, so it's kind of a first. But I figured, like, if I have a guest on the stream, I can't like have him show his face, but me not show my face. It would be kind of rude. So I decided to bite the bullet and do that. And talking about the guest today is Simon the Magpie. I'm guessing that probably most people on the stream will know who you are, but
they've heard the stories.
Yes, they've heard the stories
from the shadows.
Maybe you want to quickly like introduce yourself, if that's cool.
I'm the master of nothing. Really, I don't know how to introduce myself. I also have YouTube channel. Am I linked in the description? No, I'm linked in the title.
In the title,
because
yeah.
I knew
Yes.
you could do that.
Yeah.
I have a breadboard. Very proud owner of quite a handful of breadboards where I develop things. Also, not on your level though. Must say. But I try my hardest to create a better world for all of us who are interested in breadboards.
Yeah, it sounds very noble. Yeah, I mean, also you have your pedals, right?
Yeah,
That's
they
kind of
usually start on a breadboard.
yeah,
It's true.
yeah. But
Yeah.
then you improve the world by like making pedals and sending them out to people.
Exactly. I improve the world by trying to sell you things.
Like everybody else. Yes.
Yeah.
Right.
Indeed.
And so, yeah, we are here to actually do something that I did in the past, but I did it alone, which is reverse engineering stuff. So looking at existing circuits and then trying to figure out like how they work, why they work, and then trying to replicate them. And like I said, in the past, I did that alone, and I kind of felt a bit lonely doing it because, you know, when you're like looking at the schematics and you hit kind of a dead end, or you get into a situation where you don't quite know how to proceed, doing that alone can be very, very stressful. So I had this bright idea, I think, to just get someone else on board. And since
Someone to blame.
no, just someone to spitball with, I guess. And since I went on your podcast a couple times, you know, this just felt natural. So, and you said, I mean, you also breadboard. So I figured this could be fun. And to kind of start us off, we're trying to continue the path that I took with percussion, right? Because like on my channel, I did a lot of like videos on synthesizer circuits like VCAs, VCOs, filters, whatever, but I actually never tackled percussion. And so I thought, well, percussion is kind of intimidating because like the circuits are just weird. They're much weirder than, you know, normal synth circuits.
Yeah.
And so this seemed like something fun to like get stuck on. And you know, the last two times we did the 606, so we did the bass drum, and we looked at the toms. And this time I kind of figured I want to do something fun and something that is maybe a little bit, you know, easier, maybe a little bit quicker, because I hope that maybe at the end of this video we actually get to build the circuit that we want to build, which is the Cowbell, the 808 Cowbell thing.
Should we have a reference? Like in the... Like I have a real cowbell.
That is great. We can actually listen to the cowbell maybe first.
It's gonna be clipping like crazy if I actually go cowbelling it. This is a real cowbell. It's not a instrument or whatever cowbell. It's from an actual cow.
From an actual cow.
Yeah, I stole it.
Oh, I thought you owned a cow.
No, sadly. It would be way weirder to steal from a cow that you own than a stranger cow.
Well, I had assumed that it passed on.
No, cows live longer than humans. Yeah, outlive us all.
I find that very surprising. All right, so after we listen to the real cowbell, let's listen to the fake cowbell, right? So I found. I just
samples on Wikipedia.
Yes, I just googled the 808 and I found this Wikipedia page, and they have like a bunch of like culturally relevant stuff about it, which is interesting, I think. But they also have samples here, and one of them.
Can we turn Wikipedia into a plugin that just plays whatever samples are on whatever thread you go to on Wikipedia?
Well, maybe. Would you? How would you want to control it? You just give it a word and then it plays like the thing that is associated with the word?
Yeah, maybe. I don't know. It's a really weird idea, the Wikipedia plugin.
It's true. Okay, let's try this. So I'm going to play this. I'm actually not sure if this is going to go through. So, you know, let's see if people hear it.
Oh, yeah, I won't hear it anyways. That's a bummer.
All right, people in the chat, can we please let me know if you heard that? Well, someone said in the chat that the audio is really quiet. Okay, they don't hear the browser audio. That's a shame. How can I? That's a good. That's another annoying thing here. Let me try and see if I can add
just
it.
do it with your mouth instead. Ding.
Oh, here. I see it. So it's the. I'm guessing this should be the one. Let me try it again. I'm going to play it. Boom. No, it doesn't. It's not coming through.
Can I also ask if my audio over here is good when I sit here? Because I have a really cool setup where I can jump between.
You sound a little bit roomy, but I guess it's fine. But I don't think they hear the browser, and I'm too lazy to now set it up so that works. But I guess most people know how the cowbell sounds, right? It doesn't sound like a cowbell at all. It just sounds like a weird thing in and of itself. But yeah, that's what we're trying to reproduce today. And Simon, like I mentioned this before to you, you know, for anybody who's returning as a viewer, the last times we used the 606's service manual as a source for the schematics. And of course, looking at the 808, we now get to look at the 808 service manual. And the nice thing is that it's like much more comprehensive. Like it has a bunch more information about, you know, the chips that they use and kind of like also like the computer circuitry, if you can call it that. And then also like general information about different concepts. Like, hey, this is how we kind of generate an oscillation. This is how we do VCAs. The text is not super exhaustive, like it doesn't like explain too much about how it works, but it's nice to have like the schematic here and to be able to see like, oh, whenever I see this in the main schematic, like this is going to be a VCA. That's actually very helpful. And if we look at the cowbell explanation, we actually see a little blurb here, which I'm going to read. So it says, this sound generator uses the outputs of two square waveform oscillators with different frequencies, in parentheses, by Schmidt triggers. Each oscillation output passes the corresponding exclusive gate, which they call a VCA here, and mixed by the filter IC2. And then it says a series of resistor and capacitor connected in parallel with another capacitor forms an envelope having abrupt level decay at the initial trailing edge to emphasize attack effect. That's a bunch of gibberish. I don't know if that makes sense to you, Simon.
Of course.
Good to know.
I basically wrote this, you know.
Okay, that's great. Then you can take us through it.
Oh yeah, I got it. I think.
Cool. So you know what's difficult, like with this service manual, is actually that you have to find the part of the circuit that you're looking for, right? And it's really confusing because there's like so many different pages of schematics, and then you come to this one, you're like, oh, this is where it gets good, right? So here's like the snare drum, and then we see the hand clap and the conga and whatever, but there's no cowbell here. And then you scroll on and you get to this page and you're like, oh, this is just wiring. And then you go on and like more wiring and then more wiring. And then
whoa,
the cowbell, boom, there it is. Which, yeah, it's very buried. So if you're looking for it, it's all the way down. It's really hard to find.
They knew that nobody was going to go looking for it.
I guess. I don't know. Like, I find it so fascinating that they put this out back in the day because it's like...
it's really cool.
Yeah, it's like you just put all your secrets like out in the open. Like, here, that's the thing, right? You can just copy it. I mean, I'm guessing it's copyrighted, or it used to be copyrighted, but yeah.
I don't know. I feel like most modern quote-unquote drum machines are just super derivative from this.
Yeah, absolutely.
Like trying to mimic the sound, basically because of its popularity, I guess. If you release a drum machine now as a company, you're likely to want to compare it to the 808.
I think the sounds are just so iconic that it's like that's like what electronic drums sound like to people.
Yeah.
So
Yeah, no copyright on circuits. Yeah, you can't, or
yeah,
something like that, right?
yeah,
I
yeah.
don't remember. Someone talked about that at some point. But I want to know, like, specifically in regards to the analog drum machine cowbells. What's your relationship to it?
Oh, to analog drums.
No, the cowbell sound specifically.
Oh, the cowbell sound.
Yeah,
So I like how it sounds. It has like a very
you
like
do?
it has like a very nostalgic element to me. Like I don't think I would use it in any music that I make myself, but I always find it fun when I hear it in other tracks.
Because I personally like it. I must say, but sort of with a little bit of humor, I guess,
Yes.
like weirdly enough. But I feel like, and we don't need to plug a bunch of drum machines, but I have one here right behind me, an analog modern drum machine, and it feels like what how they implemented the cowbell is kind of as a joke. It's like a well, we I guess we must include a cowbell, but like no controls, no nothing. It's like hidden behind other things. Like you have to really switch to using the cowbell.
Yeah. So,
So,
but you think it's a joke because it's so hidden, or because of the way it sounds?
yeah, I think everyone, like in the general, but I might be completely misreading the situation, but I would assume that the general consensus is that the cowbell is the least appreciated analog drum machine type sound.
I would be very interested what people have to say about that in the chat.
Yeah.
So if you got a hot take on the cowbell, then please let us know. I'm very
You know
interested.
how to make an 808 kick drum in your DAW videos, tutorials there are?
Yeah.
There are so many. Like we're talking hundreds, if not thousands, of videos on how to get the best 808 kick,
Yes.
I guess, or like a bass note. I haven't seen a single one on how to get the best cowbell.
Yeah.
Not one.
I tend to agree. Like, I mean, I feel like the bass drum is kind of like the defining thing of the defining instrument out of the 808, right? So, yeah, the cowbell probably like lower on the spectrum of appreciation. There's some comments. So Leonard says,
Yeah.
I have friends that love the 808 cowbell. I don't. It, I wonder if that's like so divisive that it might like threaten the friendship.
Between us
No,
or them? Yeah,
no,
between them.
between
Yeah,
them. Yeah,
yeah.
yeah.
That would be weird.
That would be
But
very weird.
what happened between you? Were best of friends. You grew up together. Oh, I didn't like the cowbell.
Yeah. Yeah.
Cannot look into his eyes anymore.
Analog just said, I feel like the 808 cowbell is one of the earliest meme sounds in terms of electronic music, at least. I'd buy
Are
that.
there proprietary cowbell modules, so to speak? I don't know if I'm using the word proprietary correctly, but if you get what I mean, are there like specific? This is just a cowbell Eurorack module.
I would guess so. I'm not sure. I would have to Google it. But in the interest of time, I'm going to switch over to my iPad. I hope that you can see this, Simon, like on the stream.
Yes.
All right. Okay, so as I mentioned, like we have the cowbell right here. And you know, the thing about these service manuals is that they don't really like isolate the instruments from each other. They're just like all in a big mess. So it's like kind of like tricky to find like where the border is. But with the cowbell, you can kind of see that you have this section here, and then these two oscillators, and then this flows up here, and then over here you have the output, and up here is the trigger, and then we can go back over here, and boom. So this would be the cowbell circuit. How do I know that?
It's interesting with the square. Like I never assumed that it was square wave oscillator. Like it makes sense from like a technical point of view that that's the easiest oscillator I would assume to make. Like when they developed the sound of the cowbell, so to speak. But I definitely didn't relate it to being two square waves.
Yeah, it's actually
When I hear the sound.
they use square waves for all the kind of metallic percussion stuff. So the cymbals, the cowbell, it's all just square waves that they just mangle like in weird ways. Like if you remember, like earlier I talked about the weird VCA that they use. I think that plays a role in just like how metallic it sounds. But maybe let's start out with the two oscillators. So that's like over here. You can see that there are like a bunch more down here, and those are actually for the cymbals. And then up here you have the two for the cowbell. And there's like one thing that I want to highlight that's like really, really strange to me. So they're using these Schmidt trigger inverters here for their oscillator cores. And the absurd thing is that they seem to be using a chip that can only work with 5 volts power supply, right? Which is quite common. Like a lot of them are meant for logic levels, and so they expect 5 volts. But instead of having just a dedicated like 5 volts power rail in the machine, what they do is they take a voltage divider, they divide I think this is 12 volts, I think I saw that earlier. They take the 12 volts, they divide them with a 10K 5.7K voltage divider, which with 12 volts should give you, I think, roughly 5. And then what they do is they buffer it just with a standard like transistor. They just take a transistor here, and this is kind of set up as an emitter follower. So basically like the voltage that you have at this node here is like replicated basically here, and they send that into the chip, into the Schmidt trigger chip. And normally you would, like every normal person would just use a 5 volt regulator for that, right? For some reason they did it this way. I have no idea why. This is really bizarre to me.
Because there's a lot more components.
Yeah. Yes. Maybe it was cheaper. I don't know. And then also like they have to add like the smoothing capacitor over here, because obviously like there might be ripple in it and everything. So it's strange.
Very strange.
Really
but
strange.
Maybe it affects the tone somehow with having an like irregular voltage going or something. I
was afraid that you might say that, because that's the problem with these things. Like if you're trying to like really replicate it, then you by definition have to do everything the same that they do, right? But I think I would really prefer if we just used like a 12 volts Schmidt trigger inverter chip that I have, and we just adjust the component value so that we get the same frequency oscillation out of the oscillator. Because
are you going to use like a 4106?
Yeah.
Is that the plan?
Yeah.
Because have you, we talked about this before, I believe. It's interesting with the 4106 that the higher the voltage, the lower the pitch.
Yes. Yeah, that's because, so with these Schmidt trigger inverter chips, what they do is they, I can show this in the simulator, and it's probably easier.
Do that.
Yes. So
because that surprised me like crazy. I don't know why necessarily. I'm a noob, so that's maybe why. But
I'm gonna tell you. So if you can see the simulator, right?
Yeah.
All right. So I just double clicked on it, and that like opens like the edit component thing, and you can see here that this is set up like in the kind of like standard fashion for these things, where like the high logic voltage is 5, which you expect to be the supply voltage. So that would also be like the voltage that it pushes out. And then you can see here the lower threshold and the upper threshold. So those thresholds are like what the chip compares the input against. So the chip says like a voltage below this is a low voltage, and a voltage above this is a high level voltage. And now if we keep the values like this, and we just make this into a very basic little oscillator. So we add a resistor kind of across it between output and input. And then we add a capacitor at the input. And the values are not really important. But if we now add in a little output here, and we also put a little output here, and we look at this in the oscilloscope, This should be quicker. And let me increase the frequency. You can increase the frequency by either like increasing the capacitor value, because then it fills up and drains quicker, or you could also decrease the resistor. Rightio. And then, no, I didn't want to do that. I wanted to do this. Boom. Okay, so you can see, hopefully, that we get, like on the right side, like the actual square wave that we get out is like between 5 volts and 0 volts. That's because the high logic voltage is 5, the low voltage is 0, so that's just what it's swinging at the output between. And then here at the input, that's where it's actually interesting, because you can see that it is swinging precisely, almost, between the two threshold values, right? So if we open this back up, you can see the lower threshold is 1.66 volts, and the upper threshold is 3.33. And you can see that that's exactly like where this triangle is swinging between. And that's because basically every time the voltage rises and hits 3.33 volts, the chip says, okay, I'm going to turn off the output. So that kind of triggers it to go like into the falling state. And then when it's falling down, once it hits the lower threshold, it says, oh, I'm low now. I'm going to, switch the output to on, and I'm going to raise the voltage again. And these two thresholds, they are tied to the supply level voltage. So I think it's like the lower threshold is at 1/3. No, not 1/3. What was it? I forgot. It's on Wikipedia somewhere, but it's like it's relative to the supply. So if we feed this with 12 volts instead, which we have to simulate here, like we say, okay, the high logic voltage is now 12, and then the upper threshold actually goes up to 8, and the lower threshold goes up to 4. And if we apply this, then you can see that the oscillation is now between 4 and 8 volts, right? And that's like a high amplitude than before with the 3.33 and 1.66. Simply because the two thresholds are now further apart. And so, it takes longer for the, it takes longer. No, the voltage goes higher before it drops back down.
Yeah.
Does that explain it?
I lost you at the speed running of how fast you were at working in this simulator. It was really cool.
All right, but yeah, so basically if you give it a high supply voltage, the thresholds, the upper lower thresholds are further apart, and that means that the oscillation is going to be louder. But okay, let's get back to the pad here.
There was something interesting in chat also, like what was it? Something they had like bad transistors they wanted to get rid of and shit like that. Like I wonder how much there was another one also. In regards to the transistors that they used and how they were faulty, something. Like I wonder if that is true, or if it's like the fabricated legend in regards to the 808 drum machine after the fact, so to speak, like to justify that. I don't know how much they go for. They go for like $6,000 or something.
Yeah.
At this point.
Oh, are we talking about the quality of the sound right now, like how it sounds?
They're talking about the transistor setup specifically, like in regards to then perhaps why they are doing what they are doing.
Oh, this one here.
Powering it.
This weird voltage regulator thing.
Yeah, perhaps. I don't know if we're stuck on that, or if it's in regards to something that has more with the audio to do. It's interesting nonetheless. It is. Analog is re saying, good work, Analog. You're such a moderator. You need to turn Analog into a moderator in chat.
Can we do that?
I think you can just right-click his name.
Oh, yeah, true. I can make him. Oh, yeah, I'll do that. Boom. Okay, Analog, you are in charge of the chat now.
Yeah.
Please.
Constant co-host.
Yes. Also, people, it would be very helpful. Like, if you have questions that you want us to answer, then please like tag us in the chat so like it pops out. That's very helpful.
You can also super chat.
You can.
Wink.
I don't think I haven't activated that. I haven't activated that.
Okay. You can go to my channel and search.
All right, let's get back on track here. So, we were talking about these oscillators. So, my plan right now, because I'm not a purist, is to just like, take these two oscillators, look at the frequency that they're supposed to produce, and then we're just going to set it up so that we get the same frequency in our setup. And the awkward thing in this manual is that this is very nice. So they tell you like, hey, this is the pitch of this oscillator, and this is the pitch of this oscillator. But strangely, they put it in milliseconds and not in hertz, which I find very weird, but that's how they choose to do it.
That is weird.
It's their prerogative, I don't know. But I found, actually, like when I was researching a little bit beforehand, shame on me, I found this nice little converter. So you can convert milliseconds to hertz.
Can't you start doing that with all your modules? Like in the manual, you put the frequency in milliseconds.
That's a great idea. Just to fuck with people, yeah, that's a good idea.
Yeah.
All right, let me put this in here. So the first oscillator is supposed to have a frequency of 1.85 milliseconds, which is 540 and 54 hertz. So I'm just going to write this down over here. So in normal people language, this is 540 dot, I'm not sure that's important, but 454. All right. And then the other one is 1.25 milliseconds, which is 800 hertz. That's easy. Okay, good.
But so you're gonna do it with fixed values, I'm assuming then.
So here's the strange part about like this about this whole setup. Like here, if you look at the oscillators, you can see that they use trimmers, right? So this is a trimmer and this is a trimmer. But they're not exposed on the panel. Like the panel does not have controls for the cowbell. I think it only has, what does it have? I think only volume actually. We can look at the 808 panel really quickly.
So they had an intern sitting and tuning all the cowbells.
So the strange thing about it is, let me find the panel. This one looks good. Of course, it's Wikipedia as always. So yeah, you can see it only has a level. That's it. Level dial. Oh no, wait, that's the accent. I'm talking bullshit. Cowbell. So only a level dial still.
That's very much the same on the, someone mentioned in chat before, the Arturia Impact. I think it's the same with the Impact. You can't tune it or anything.
Yeah, it's weird, no?
If I'm not remembering wrong.
Because it would be very easy to just like expose these pots like on the panel and then you're good. But
yeah, and there's seemingly a lot, like there's a big chunk of the drum machine row going down there where they could have put.
Absolutely. I mean, maybe that's actually going in the direction that maybe Roland themselves thought of the thing as kind of a gimmick, and maybe they were like, we're going to put it in there, but we're not going to give it any love, maybe. I'm not sure.
There's another conspiracy theory. Because it was a budget drum machine when it came out. Right? Yeah. It was like a cheap thing. Maybe they thought that, okay, we release this and we release all the documentation and we hope that people start like tinkering with it. We leave a bunch of space here on the physical faceplate where people can put their own pots and stuff. Maybe. It's a conspiracy.
I mean, it kind of like, I think you're right. Like with the whole manual being like this in detail, like it kind of feels plausible. Yeah. But you know what's weird about this setup is like, so these are trimmers, right? So they are factory set. Like like you said, someone has to sit there and like tune every 808 before it goes out. Now here's the weird thing, right? So I'm assuming they add the trimmers like to compensate for any like component tolerances, right? Because these resistors here and also these capacitors, like they might not be the value that they need, right? Because like with capacitors, very notorious, like they sometimes have like tolerances of up to like 80%. So you buy like a 1 microfarads capacitor and could be like 1.8 or 0.2. So fucked up. So yeah, it makes sense that they have to compensate, but the trimmer value is crazy. It's 220K.
Yeah.
Like that's a huge range.
But where do you even find Was it like a 500K trim, like, or was it a 220K trim?
What do you mean?
Where do you find that? I wonder if the 220K, is that the value it's supposed to be on the that's where
No.
you're supposed to set it.
That's the whole trimmer. Like the whole trimmer has a range of 220K. And
Where
then
do you find that?
I have no idea. Probably exists somewhere.
Yeah, I would assume so.
Yes. But so for our purposes, we just need to know, we need to get like this 550.54 hertz on one oscillator, and then we need to get the 800 hertz on the other. And we can quickly whip that up in the, oh, not on here, in here. Let me switch over to the browser. Boom. Okay, so we've already got this set up, which is nice. The cool thing about the simulator is that you can also have it show you the frequency of the oscillation. And you can see here that we've got 714, but we want to go down to 550. So I'm just gonna eyeball this thing. And I'm just gonna like change a little bit of these values, and then I hope that we get into the ballpark. So that's 320. Let's do 200K.
What was their original values? It was like 0.022.
It's, oh, maybe we could just go off that. You're right. So
what is that? That's like 2.2
so
NF,
they have,
I would assume.
they have 22 NF on the cap, and then they have up here, they have 150K. 150K is 217. Okay, so basically, I guess we need to take the trimmer, we need to add half of the trimmer to the 150, and probably that will give us like the value that they actually want, I'm guessing. So that would be 250, 260. Let's try that.
Let me have a little bit of a look-see. So 150K.
So that's actually wrong. That's 126 hertz. So let me try 120K.
I wish I had like a components angle. I'm feeling now, like where I grab, I don't know if you can see now, where I grab all the components. If I could just, really, really cool.
That would be cool. Okay, so I just realized that I'm an idiot. Like, of course, their values are not going to work because they, like we said earlier, like they run their chip at 5 volts. I run mine at 12. So it's not going to match.
I'm setting it up on 5 volts here in the physical world. So I'm going to do what they're doing quite literally.
Very good.
But with a 78 LO5 instead.
Perfect. So we get the button. Do you also do the weird thing with the transistor?
No, no. I do a voltage regulator.
All right. All right. Okay, so I think that I will need to do 51K, and then I will take a trimmer because, yeah, the capacitor is probably going to be wrong. And the question is, well, what value trimmer I need? Let's try with 10K maybe.
Let's see. That should be from that one, yes, and then from that one, yes. Yeah, I don't have 220K trimmer pots. Just
why not?
One can wonder, indeed. I should have some 500K though.
That's good.
Yeah, that's just go. I mean, I can go 100K. I can go, but that doesn't reach it.
Okay, so I think I can get there like this. Okay, so I'm gonna have to, because I think I only have 51Ks. I think that's like, the next thing I have is like 68Ks, but that's gonna be too much. Let me check my stash. 68, 51, 82, 66. No, I'm gonna go with 51, and then I'm gonna cheat a little bit. I'm gonna add a 4K7 in series, and then I'm gonna do the trimmer.
I'm doing 100K trimmers or like pots.
Is this a competition now?
No. What? Who? What? How would you win this
If you're
competition?
faster.
Okay, okay. I thought it was like if you have a bigger value.
Yes. Well, okay. This is awkward. You know, like when I wasn't showing my face on camera, like I didn't have to think about like, can people see me?
Smiling.
Am I visible? Am I approachable? And now it's just like, oh, it's like another thing, you know?
So I'm smiling compulsively when I make videos.
Aggressively. So I just found this little chip here, which is a 4106. I'm a little bit concerned because it has, I don't think you can see that, but it has like these non-shiny legs. You know that? When they look like a little bit like roughed up. And normally that's like an indication that they're like fake. So I hope this one isn't fake.
How can it be fake?
There's fake shit. Like once I tried.
Would you go? Why? Sorry, why would you go through the effort of faking a Schmidt trigger?
I don't know. Like once I went on eBay to like just buy like a bunch of them, and I got them like from Taiwan or something, and they were like extremely cheap. It was laughable, and I got like 100 of them for like €5 or something like that, and they barely worked. Like most of them were just broken. They just didn't work.
That is weird.
Yeah.
That is weird. That is weird.
All right, so I just had to look up the pinout because I completely forgot. It's been a while since I last used the chip.
Number. I also have cheat sheets. 1, 2. One is backside.
Yeah.
Like it goes in that direction.
Backside? What do you mean? What's backside?
The backside of the triangle. Illuminati.
Are you looking at the chat, by the way?
Of course I am. How dare you second guess me?
Are people asking anything?
Yeah, resistors are much cheaper than caps. It's true.
That's true.
What type of cap are you going to go with?
I'm going to go, like I always use, a nice film.
Like MKT or whatever it's called.
These ones here. I think the company is called Vimo.
Aha. Ooh,
they're very nice. I like them.
Okay. I like these. The tiny. I don't have as cool of a setup as you, though. But you know what I mean.
Is it like electrolytic or ceramic? Or film?
Film, I think. I don't know. MKT? Something? I have no idea. They're small. That's nice when I build PCBs.
That makes sense.
Yeah.
What do you think of tantalum capacitors?
I think I have a couple because do you know the sample and hold circuit? The yet another sample and hold, the Yash?
Yes.
With the LF398?
Isn't that like a René Schmitz thing?
No idea what you just said. Didn't sound like real world.
There's this guy called René Schmitz who has like a website and he has like all bunch.
Yeah. I think he's the one behind the Yash. So it's the most. But I think he talks about you having to use one of those fancy, crazy, alien egg-looking capacitors.
Oh, because they hold the charge better, or why? Yeah,
but I was able to hack it, and now I can use these way cheaper and more accessible caps.
That's great.
So that's really nice. Yes. I don't know what I'm doing though now. I feel like with your setup, it looks like I'm doing that.
You're doing what I'm doing.
Yeah, it's like I'm looking at my hands.
Right.
When you move your hands.
But wait a sec. Like, did you already set it up? Is it already done?
Yes.
Oh fuck. All right. Can you make a sound for us?
Yeah. If you, what's that? Look over there.
What?
No. I'm not done. Is what I'm hinting at.
Okay.
But I'm soon done. I think. I don't know.
Wait, 103 is 10K, right? With trimmers.
Yeah.
I think 104 is 100K, 102 is 1K, and I'm only getting those two.
105 is a million.
I should really put these in like marked bags. This is ridiculous.
Okay, I'm just gonna do like that. I think might have to switch it up later. And then we're doing like a double trouble here. I guess 2 oscillators.
Well, it's gonna be.
I glue them together with a 100K resistor, or how did they do it?
Yeah, they just mix it with. I think they use like 120K for whatever reason, but yeah, that's how they do it.
I don't think I have 120 actually. I have 150.
Just use 100. It's fine.
Yeah.
It's gonna be loud as fuck though. Oh no, you use 5 volts, so it's gonna be okay. Yeah.
Yeah.
Yeah,
I can go through also.
Mine are gonna be crazy loud.
Just bring it down.
I only have 102s and 104s, but no 103s. This is sad. Oh my god.
Let's see. How do I mean, I can plug it straight in and you can hear it if you want to, but or I go with a speaker. That might be better.
Well, if you go with the speaker, then I guess everybody can hear it, right?
Yeah, but I mean, I could make it be one of my mic input. So instead of my voice, you hear the. What am I doing?
That's probably even better, right? Especially if you're trying to annoy people.
Yeah, with the cowbell without a VCA.
Oh God. Where's the 103? 104.
See how we get audio to begin with.
102. 102. Jesus Christ. More 102s. I'm beginning to believe that I might not have 103s.
That's a bummer.
But did you put any trimmer in there, or did you just like put the thing?
Yeah, I think I did.
Oh, here's a 20K. That's... Oh my god.
You hear this?
It sounds like screams from hell.
I can do it. Yeah. Good shit.
Very nice.
Do you want it to be louder?
Please.
Sorry. I got excited.
Yeah. I can tell.
It's weird that it's picking it up that well, though. Actually.
Did you blasted it like just like through the speakers, right?
No, it was just an amplifier, but I mean, it wasn't loud to be annoying for me. Like it was a pleasant level in the room, so to speak.
Yeah, like on here it was screams from hell.
Yeah, that's really cool. With how the all of these. I know this is a weird subject to talk about, but for example, if we were on Discord right now, it would probably try to cancel out the sound. So it wouldn't be loud at all, but in the one we are using now, it basically emphasized the sound then.
Yes.
Just fascinating stuff.
It's true.
Really.
Yes. I'm so slow. Jesus Christ, you're already done. You already tuned it basically, and I'm like still fumbling around like an idiot here.
Tuned it or tuned it depends on where you want it to be.
Well, maybe we should just like split the work, right? I just explain the thing and you just build the thing. How about that?
Yeah, I mean, I can do a oscillator fun fact. If you want 50 of these oscillators in a box, I got you covered. So,
all right, let's just.
This one is really cool, by the way. Plug.
It is.
Magpie Pulse. It's not even released yet, but it's like a limited edition super paint job.
What's the paint job?
Edition. This is the paint job.
It's very small. Wait, let me make it bigger. All right.
It's like abstract. Wow, right?
That's really cool.
Cool. Do you know how long it took me to just put the knobs on here?
No, how long?
Probably 10 minutes. Just imagine that.
Impressive.
Um,
All right, let's redo this. Like, I feel like it's maybe more efficient if you build the shit and I just talk about the shit until we hit a wall. How about that?
yes.
That sound fair? Okay, good. So you've got the
Where's the wall? Let's look for it.
So you've got the oscillators, and you've got like regular potentiometers, right? So you can just like tune them against each other.
Yeah.
Okay, cool. Right, then let's switch back to the schematic. And so now we have...
How do I measure the milliseconds?
You could use a tuner. I don't think it's really like important that we tune it right now. But so yeah, I mean, in essence, if we did use a tuner right now, we did tune it to that frequency, then we would have the exact thing. But I guess it's fine. Okay, so you just mixed them in with these two resistors here, right? You just used 100Ks.
Yeah.
Okay, perfect.
I also put a cap after, but I mean, that's just for safety, I guess.
A cap after it.
Yeah, I run two 100K resistors into a 1 oof cap, and it just brings down the voltage completely.
It also filters it. It's a low pass filter.
Yeah. Yeah, but it lets everything through because it's such a big value.
All right.
I don't know, in my humble experience.
Oh, you put it in series, not to ground.
Yeah, not to ground. In series.
In series. Okay, then it's actually not a low pass. Okay.
Yeah.
Okay. All right. Let's move on. So we can see that next what they do is like they reduce the volume here, right? So they take the output and then they wait a second.
Oh, and they just divide.
Oh, look at this. They don't even. I was wrong. Like they dual purpose these things. They use them here for the cymbal stuff, but for the cowbell they go here and here. So the 120K is actually not related to the cowbell. They actually don't do that. So what they do is like they just divide it down like here.
But how do they mix them if they don't go through resistors?
That's what's coming up now. And it's a very good question actually, because maybe you remember this from earlier, like what we saw in the other section of the manual. They feed both of the cowbells. Well, first they divide them down, but then they feed them into these weird things, which are actually VCAs. Like this entire thing, this here, that's a VCA, believe it or not.
Yeah, I believe it. I believe it. I think I've tried that VCA, like based on I think there are a lot of screen prints of that little image that you showed in the beginning of the stream of a VCA, because it's like the simplest VCA ever, and it just doesn't really work very well when I've tried it before.
Yeah. So I think, let me switch to this is the whole manual. We can switch back to that section of the manual.
Can I ask a question really quickly though? Yeah. Do you mean that they do separate VCAs for the two square wave waveforms?
Yes.
That is bonkers.
Why?
Don't you think so? I think it's bonkers that they do two VCAs per oscillator. Or like one VCA per oscillator to create the cowbell.
I think they do that because I think that's what they mean here. They talk about how a series of connected in parallel forms an envelope having abrupt level decay. I like my assumption is
a really short decay.
I think they affect like both VCAs in different ways, and that kind of gives it like a special like kind of attack sound.
Like a wah.
Yeah,
sound.
Like a flam. If you do you play the drums?
That's exactly how a real cowbell works.
Well, if you play it as a flam, right? But okay, so yeah, you mentioned that this thing is strange because they call it a swing type VCA. But you can see here, like they show you already, like they feed it a sine wave. Also funny that they hand drew this. It's interesting.
Yeah.
So they feed it the sine wave as the signal input. They give it this kind of capacitor discharge curve as an envelope, and then if you look at the output, it does like replicate the envelope, but it's not. This is not a sine wave, right? This is a
That's how I hand draw a sine wave.
But I mean, they've proven that they can kind of draw a sine wave, like approximately, right?
It's true. So maybe it was two people having, when you fold a paper and one person draws the head and then the next person draws the body, and then you pass it back and forth.
That's what might have happened here. Yeah.
Yeah.
But we can just set it up in the simulator and like see what happens, because it's a very quick circuit. So I'm going to do that now. Let me switch over here.
Would you recommend a BC558 as the transistor, or?
You have to use an NPN, so you have to use either a 23. What are they?
I have like a 2N3904.
You can use that, or you can use a BC548 or 547 if you have. Doesn't matter.
I'm gonna use all kinds of stuff.
Okay. Fair enough. Okay, so let's set this up. So they got a transistor in here, and then they have a ridiculously big capacitor for whatever reason. They have a 10 microfarads capacitor at the base. I don't understand why. That seems ridiculous, but okay. Then they have a 470K resistor over here, and that thing goes to the power supply, like that. And then
so to 5 volts in my case.
You don't have 12?
I am 9.
I use 9.
Yeah.
And then there's a diode that goes into the collector, like that. You have diodes, right?
Yeah.
Good. And then I think this is where they feed in their envelope already. Yeah, they.
Is it a 10 ohm resistor?
Down here, oh no, it's 100 ohms.
100 ohms.
Yes. Right, and then they use a.
I actually have 10 ohm resistors. Sorry for interrupting, but such a ridiculously low value.
Yeah, I mean, people use them as fake fuses, right?
I don't know why I use it in something. I think I use it for just a really, really weak LED or something.
A weak LED?
Yeah, like that does it. Like if I put 1K resistance on the LED, it doesn't do anything.
It just needs a lot of current, basically.
Yeah.
All right. Okay, this is actually it. Like this is the version of the thing that they use in the Cowbell. And now if we take let's just do what they did. Let's just take a sine wave and take a quiet one, because I think, they divide the Cowbell down so much. I'm going to just use a small one here.
But the Cowbell is square wave. What am I missing?
Well, I just want to see like how badly it mangles the waveform, and you can.
Okay.
I feel like the best way to see it is like with a sine.
Yeah, that is true.
And then we're gonna take a saw, because that's almost like what a envelope is. Oh, but I think this is going in the wrong direction, right? This is like rising up. It doesn't matter. It's fine. Oh, that doesn't work. Oh, maybe they don't expect negative voltages here. Let's try that. I'm going to push it up so that it's like above the 0 volts line. It's still the same. Did I do something wrong?
It's almost more likely that they just painted it wrong and never got back.
No, look, the problem was that the capacitor, the huge ass capacitor, was just charged up, and so like it didn't work. but now it does work. Yeah, you can see that it's like it's a sine wave input, right? And it puts out a square wave basically. Like it's a pulse wave. It's actually like not 50% square, but it's like very narrow pulse kind of.
That's fascinating stuff.
I wonder what happens if I drop this resistor value. Oh, it's just the same. It doesn't matter. Okay. For 70K. Still the same. All right.
Huh.
Okay, let's turn up the current speed. Right. Okay, so what's happening is basically that we have a voltage up here, right? So it pushes against the resistor, against the diode, and then against the transistor. If I disconnect this thing here, then what happens is that the resistor doesn't, the transistor doesn't allow any current to flow, and so the voltage here is untouched, right? Because no current flows, so voltage stays the same, everyone's happy. But then if we add in, well, first this resistor, basically what happens is that we turn this guy here on. So this is kind of just like biasing it, so just like turning it into the section where it like just barely turns on. And then if we add in the oscillation, what happens is that every time this goes low, so below 0 volts, basically we pull the voltage at the base low, and that means that the transistor blocks, and that makes the voltage here go up again. And every time the oscillation goes high, basically it opens up the transistor more, and that means that current flows to ground and the voltage here drops. And the thing is just that the resistor, the transistor is just like almost either on or off. And so that means that, you know, you get this square wavy thing where just like, you know, you can see it here, like every time the input signal goes low, you just have this ultra sharp drop and then it jumps up again. And I'm pretty sure that this is like how they make it sound metallic. Like if we switch this out for a square wave.
Yeah.
Actually, it's just a square wave, right? Interesting. Oh yeah, because it's just on or off, right? And then the transistor just like replicates on or off. If it's on, voltage is low, output voltage is low. If it's high, output voltage is high. But then since we are having, since the the envelope voltage is just like slowly rising, that means that the output that we see is like also just rising in volume. So yeah, that makes it like a really shitty VCA, but it is a VCA that apparently like works pretty well for square waves. It doesn't work that well for sine waves. Does that make sense to you?
It does. I just I need to create the entire envelope thingy on a breadboard.
Oh god.
I guess.
All right. Yeah.
If I am to.
How are you faring there?
Now I'm doing experiments here instead. That doesn't work.
Do you have an envelope somewhere, or do we need to also build that?
I will have to build that in that case. What? How do they build it?
They just use, so they are like a trigger circuit, and that just feeds into a capacitor. And since like, you know, current is draining out through the transistor anyway, you just add a capacitor and then that drains out through the transistors, and that's your envelope. And it's not variable, so it's just like fixed, you know, fixed decay.
Yeah.
So I can, wait, if I go back to the simulator, I can actually just add it in. Do you have like something like a push switch?
Yeah.
That's good. Okay.
I'm trying some weird experiments now. I was thinking I could trig it with piezo or something just for fun, but I couldn't. That's a bummer.
It is.
But I should be able to.
I think you can just do the following. I think you can just do this. You just add in a cap over here. This value that they specify is, let me check, 470 nanofarads. And then you just add in the switch over here, Oh, okay. That crashes the simulator. All right, so you should probably put a resistor here.
A great sign.
Yeah, actually, the simulator is like pretty finicky when it comes to like capacitors. Like, it doesn't like it if there's like a voltage source directly connected to a capacitor. Which in real life, like with smaller values like this, like it's not gonna fry anything. But can never be too careful, I guess.
Have I shown you my really cool soldering light?
No. Show me. Oh yeah, it's with the integrated smoke sucker thing, right?
Yeah. So I need to solder a button, I guess.
I'm gonna throw up the browser again for you, so you can see what I did here. But yeah, it's really just like adding a cap, adding a switch. That's it.
That's kind of wild that they do it so easily.
It's got to be cheap, no?
True. What is it? But how is it? Then it's just based on how long I hold down the button.
Well, if we like, I mean, they have like their CPU sends out like very quick pulses, and so they don't have this situation where you might hold it for longer. For you now, like the idea would be that you just like quickly push to let it go. But
well,
yeah,
why don't I could just use square wave from another square wave from the 4106 instead of a button.
Sure, could do that.
Yeah, that might be easier. Just a really slow one.
Sure. The issue is if you make it really slow, the wave cycle is going to be very long, right? And so the high phase is also going to be very long. If you want to do that, then we need to add like a gate to trigger converter before that.
Yeah, you can do that really easily with the Schmidt. Just add a diode.
Oh, true. And you can narrow the pulse width.
Yeah.
That's true. You want to do that?
Yeah.
All right, let me check the chat. I feel like we haven't checked it in forever.
Yeah, add some incentives.
So DDC asks about...
Hey, DDC!
He asks about if he missed a Simon moment, like the Fourier transform one. Did he?
What did I do?
I don't know.
Fourier what does that even mean?
Yeah.
DDC. You Italian. Don't even know what you're talking about. Also, hey, Veer.
Hello, Veer. Hello. Who else is here? Sandalinos. Analog made fun of your smoke sucker.
That's rude.
It is.
I'm gonna make fun of your smoke sucker. Ass in your face.
Oh, Sean suggested that we could increase the emitter resistor of the transistor to make it like not mangle the sine wave so much. I guess that could work, but I mean, since we're working with square waves here anyway, like we don't care.
We can try.
I mean, it's not going to make a difference with the square, right?
Are you a naysayer?
I mean, also you're changing the. We want to be. I mean, we don't want to be that faithful, but like to get the proper cowbell.
I don't see why we wouldn't want to add the rest of the oscillators from the 4106 in the end to do a 6 oscillator cowbell.
I think then you're getting into like symbol territory actually.
That might be true.
Yeah.
I don't know.
I don't think we'll make it. Like we now have officially we have 1 hour left because we said we have a 2-hour limit. We just blew past the first hour. But I'm optimistic. Like if we get the VCA set up, then there's only one thing left, which is like a filter. The filters the sound. That's it.
Okay, we do that next stream. Part 2. Because we need to discuss. We need to evaluate. We need to, I don't know, judge each other.
So Analog says it's interesting to him that the same source is used on a symbol and that he wouldn't have guessed.
Yeah, same
It's
piece.
it's yeah, it's interesting. I like from what I read, apparently it's like all in these VCAs. Like these VCAs, they make it sound the way that it does. But it's also weird because there's this very like I recommend it very highly. There's like this series called Logic Noise. It's on this website called Hackaday, and the guy, like, he explains a bunch of like cool circuits, and he does it like extremely an extremely simple way. And he has like one article where he talks about synthesizing a symbol, and he actually talks, like, he references like the 606 and the 808, and then he explains like how he does it. And he uses an XOR gate, which is like a logic chip that it always takes two inputs, looks at them, and it only gives out a high output if only one of them is high. And if you do that and you mix just a bunch of these oscillators together with that, you also get like this extremely like aggressive metallic sounding.
Yeah, you get like a digital noise sounding thing.
Yes.
I know Sorcery, like Christian Blåsol, who also does a bunch of modular DIY stuff, fellow friend actually. He showed me doing that with a 4106 and a 4070, I think. So you just use the 6 oscillators to create noise, which is nice. I have the pulse now. So what do I do?
You have the pulse now?
Yeah.
What do you mean?
I have a little pulse here. I don't know. I can show like this probably. Maybe. I don't know. No. Hard.
Do you have an oscilloscope there?
No, I have an LED. But I lost the battery. There we go. So it goes blink.
Yeah.
Blink. Blink. Perfect. I can make it slower later.
Yes.
If we need to. So then what?
Well, you also set up the VCA, right?
Yeah, I think so.
Did you add in the capacitor at the input?
Can you bring it up?
Sure.
Again.
Here.
So input straight from a square wave.
Yeah, like
into 10-ohm.
Where my switch is right now, you take your spike, and then you just feed it into a cap, and you connect that cap to the input of the VCA.
La 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 la.
Wait, was that you or was that the circuit?
That was me. Oh. Would have been cool if it was the circuit.
Yes.
But if I don't know where you mean. You haven't done it in the simulator, right?
So
I don't see that. I only
see here. I'm gonna put the pulse. This is gonna be a pulse. That's the thing that you get. And then I don't think you need this one, but in the simulator we need it. So you add the pulse, and the pulse like pushes the current into this cap, and then the cap is kind of like generating the envelope. Oh wait a second. Oh no. You have to. Oh, okay. You don't want the cap to discharge in this direction, so you should add a diode here.
Diode. Okay.
Because otherwise, it's gonna the cap is gonna just discharge into the.
Yeah.
Yeah.
So, pulse go into a diode. Diode goes to a tiny resistor and then a big resistor.
You don't need the tiny resistor. It's fine.
But I need the big resistor.
You need the big. I mean, the big resistor is part of the VCA actually.
So we go big resistor, and then big resistor goes into a second diode that goes over to that one over there. Very nice. And then we have 470K there and 100 ohm there, and then I just need the capacitor. I only have 330 NF.
That's fine.
We hope.
I guess so.
And that should be before. There. Ta-da! Now we listen, I guess.
Yeah. You can pick the signal up after the 100K.
Okay. I only get the click.
Oh. Oh, that's the click.
Yeah.
That's weird. You did connect the oscillator to the...
Yeah. That's what I mean. I have tried this VCA before.
It just doesn't...
Results.
Interesting. You
can
have...
lower the... I can lower some values.
Well,
for the
so
fun of
a couple of questions. Like this diode you have in there, right?
Yeah.
Okay. Do you have... Jesus Christ.
Wow.
So you connected the output to this point, like to the where the diode points towards the transistor, right?
Good. Let's see why I get the signal through when I do that. That's really weird, actually.
You get it through when you do what?
When I do a thing, I can switch cam. Here. It's weird to look at the table. Here I am. Not at all weird to look at me. Can I zoom out somehow? Okay, it wasn't super dramatic. Yeah, it's a bummer.
So you're picking up the signal from this point, like in the between the 100K and the second diode, right?
Yeah.
All right, and you have the resistor that's going to like your positive rail at the transistor space, right?
Yep.
Do you have a multimeter?
Yep.
Could you measure the voltage at the transistor space?
Yep. Oh. But I can also do the thing really quickly, just for the fun of trying it. Because now we're not hearing the pulse either, weirdly enough.
You don't get the pulse anywhere?
No, I'm not hearing the pulse anymore. Like, we heard it. Oh, okay. Yeah, of course, because I lowered the volume. Okay, but if I up the volume, I still don't hear it.
Battery is plugged in?
Yeah, the LED is blinking and everything.
That's weird.
So
you don't even get the pop, right?
No.
That's strange.
Why? Okay,
that's the pop.
Okay. So far, so good.
But the oscillation's not there?
No. It also very much doesn't like VCA it, so to speak. Right?
Wait a second. Did you divide the output of the oscillators down?
No.
I think you have to do that.
But that is really peculiar. Like, I would assume that louder oscillator would leak through, not give me only the pulse.
So let me try it in the simulator. Right now I've set it to like oscillate between plus or minus 1 volt. If I push it up to 5.
Yeah.
Oh yeah, it should still come through.
We have a cool kick drum though. Over here.
It doesn't have any bass though, does it?
Nope.
Okay, so it shouldn't matter like how loud it is. Okay, you're right. That is...
I would assume louder is better even.
Well, it's gonna be more clear, I guess. Like it's gonna come through clearer, maybe. I'm not sure. So you did also use the big 10 microfarads capacitor, right? Like at the base.
Yeah.
Okay.
Yeah.
Could you measure the voltage at the base?
Yeah.
Real quick.
What were you saying about the 1 hour thingy?
So if you remember, I think on your podcast we talked about the stream, and we were discussing like how long it's gonna go. And in the past, like I often just like let it run until I couldn't do it anymore. I don't think that was a good strategy. So basically, I just thought it might make sense to set like a time window, and I thought it would be good to set it to 2 hours. And since we started at like 6:45, we have 45 minutes left.
Again, okay, what the? So it says -7 volt on the base now.
Constantly?
No, it's moving around completely.
So it's also going up?
Never above negative.
That's interesting. Like in the simulator, we can see that it should be switching from like -10 to like up to like 500 something millivolts, like to turn the transistor on. Wait, let me make you big.
It's behaving ridiculously.
Can you show it again? Can you show it again? Closer. So it's stuck at -4 volts. Can you measure the voltage at the oscillator's output? Oh, wait a second. Are you using like 100K to feed the oscillator into the thing?
Oh yeah. No, not anymore. I did for a second, but then I stopped.
Okay, and didn't change anything, right?
No. But I'm curious if I do other things.
What other things?
Just get rid of a resistor and do a jumper.
I will just in parallel also set the thing up here.
Yeah.
Let me know if you need to see the schematic.
Probably at some point.
Yep.
But not now.
Okay, let me see if I get some oscillation here. I think I should. Watch out.
Maybe we need those faulty transistors.
Yeah, maybe. Okay, let's see. Oh god. Alright, that works.
You get it to work already?
Well, it's just the oscillator. It does sound strange though. So I think that the chip might be broken. But actually we don't care, like the oscillation can sound horrible, that's fine. Because we just want to verify that the VCA works. Okay, let me set up a cap. This is why it would actually be better if we just were in the same room, eh? So you're just getting like a constant thing now?
Yeah, I broke it. I broke the VCA on purpose.
So what, you changed the setup? What did you do?
I don't know. I figured it out eventually.
Alright.
So that one is just a ground.
And then we need a jumper.
It's so ridiculous because it's like 5 components.
Yeah. Oh, you mean it's ridiculous it doesn't work?
Yeah.
That's true. Let me find 470K. Well, did you just get like the kick and the oscillation?
Yeah.
Interesting.
I'm making my own synths now.
Like a very, very avant-garde bass drumming. Oh my god.
I'm touching it.
All right. 100 ohms.
You know, I'm gonna switch to a MOSFET transistor.
You think that's gonna fix it?
No, it's probably not, right?
No.
There's no logic in that fixing it.
Okay. I mean, let me try. Like I'm almost there, I think.
Yeah.
And then we can
You
see.
try.
Can see what happens. So emitter goes to ground through 100K, like so. And then we have the diode. And the diode goes to the collector, like so. Boom. And then, did you maybe, like, which type of transistor did you use?
Now I'm on a MOSFET.
But what did you use before?
2N3904.
Are you sure you, like, about the pinout, that the collector and emitter were, like, in the right orientation?
Yeah, I even tried switching it back and forth just for the sake of sanity checking, you know.
Yeah. Yeah, that always trips me up. Like, they have opposite, like, from the BCs, like, the BCs have, to me, it's sensible, because if you look at the transistor from the front on a BC, it's like collector base emitter. That just makes sense to me. And then with the two ends, it's just like reverse. It's emitter base collector.
It's a peculiar component.
I think so. I mean, it's much more popular. People like it much more, I think, but still.
Yeah, I wonder why. Maybe it's because it's confusing with how many different numbers there are for the BC.
Maybe. Yeah, but I think I read somewhere that the BCs are like a North American thing. The fuck was that?
That was just my kick drum.
All right, I'm almost there.
Yeah, turn it off. Yeah, hopefully you get it to work. No, I'm gonna switch back to this table.
I'm in the final stages of it. Okay, so that's that. I'm using a 1 microfarads instead of, what were you using instead of the 4700?
330.
I wonder if that's what's gonna make it work.
I think I tried with one oof also.
Okay.
I tried a lot of swapping.
I was just gonna say, you tried a lot of shit already.
Yeah,
right.
It's my general approach. I saw DDC commenting Simon and multimeter. I just try everything instead.
Yeah. Sensible. All right, that's that. And now I'm going to use the push button just because I don't want to set up the additional oscillator. If I can find it. Where did I put it?
I can talk to chat. I need to zoom in.
Yeah, please talk to the chat. I feel like we're neglecting the chat.
I have been deep down in a breadboard.
All right, I got my push button.
You heard it here first, kids. You should never do the 808 VCA.
What? Why?
It doesn't work.
Let's see about that. Okay, I think I got it. All right, this is gonna get ugly because I feel like it's gonna be loud. Let's see.
I'm ready. 808 VCA is a lie.
Look, it already works.
Yeah, okay. Good for you.
I mean, it sounds weird as hell, but wait, let me use a smaller cap. Maybe it's actually the transistor, right? Because I'm using the BC one.
Yeah, it might be that it doesn't work with the 2N.
How
And
does
the only BC I have is the 558. So when I look here, maybe in a box somewhere.
All right. Let's try this one. Ugh. So I'm gonna go for like a really tiny cap right now.
But what did you go for? A BC
548.
5. Yeah, I'm gonna look in the box.
Okay, let's see. Oh. That's weird. I don't understand why this chip is misbehaving so badly. You know, it's just like... Also, like, you get like this bleed, right? So the sound is just like bleeding through constantly. And let me try a different value capacitor. So this is a 22 nanofarads. I'm gonna switch it for 100 nanofarads and let's see what happens.
Okay, I have like a plethora of random ones. So I can try with all kinds of weird stuff. BC 108.
Well, I mean, this doesn't really sound like a cowbell. But
BC 1.
it does the thing that it was supposed to do, I guess. Okay, but I'm really curious, like, why it bleeds through, like, even after the voltage is supposedly gone.
Is it okay if I express a lot of jealousy that you got it to work?
Sure.
I'm very jealous. You got it to work.
Dude, it might just be the transistor. I don't know. Also, I hate that my chip is just doing this weird... Like, you hear, like, how it's, like, weirdly... It sounds like it's dying. I don't like that. Let me try a different one. Alright.
Is your room also just covered in components?
Yes. Super annoying. It's the same shit. Wait, let me check my setup. So we have positive voltage coming from here. It's connected to the cap. If I push the button, the cap gets filled up. The cap then discharges through the 100K, through the diode, and through the... Well... Oh, wait a second. No. I thought maybe, like, because we bias the base, you know, we give it a constant current through the 470K, maybe that means that the VCA is, like, constantly a little bit open, but that does not seem to be the reason.
Here's a spring reverb.
Say it again?
Good stuff. Here's a spring reverb.
Nice.
In the category of good to have.
Definitely.
But what is your issue now? You get some bleed through? Is that all?
Well, you can hear that, you know, I push it, I let go and it slowly declines, right? But it never goes to 0. And I don't know why it doesn't go to 0. That's strange to me. Also, it takes a long time to drop.
Yeah, but you can just lower the cap value then, probably.
Well, if I do it 22 nanofarads, like so.
No, try with like 1, just for the sake of having tried like a drastically lower, then you know.
So so you assume that it's just like still bleeding, still bleeding, still bleeding, and that's why we get the.
It's a theory.
All right, let me try.
It might not be the right theory, but it's a theory.
All right, let's try this again.
Damn it! Now I have to set it up all from the beginning because I did so many stupid things.
Wait, maybe is this the right transistor? So this is a.
But are you going straight from the 4106 into it? Also, no resistor or anything.
No, I'm using 51K here. Like that goes into the cap that's connected to the transistor space.
Okay.
Yeah. And then
YOLO. YOLO. Okay, then 100K to ground. Why?
oh, so Analog says there's a couple good thoughts above. So Analog says the bleed goes away when you touch the diode. Yeah, I noticed that. Like, I'm not sure what that means. That's okay. Superstring Space Corrupt says unused inputs of the chip may catch interference from mains and cause a whole bunch of weird stuff. It's better to ground unused inputs. Oh, that's true. That's true. That's very, very true.
But I've never really like encountered to the level of like audible stuff.
Oh, I did. So like a while back, I built this module that has. Or that uses like one 4106 to do like 3 VCOs.
Yeah.
And that was actually a nightmare because when I built that, I was just assuming, oh, it's all going to work out. And I didn't ground the inputs at all. And it caused it to just sound like screams from hell. And then I did ground them, and then it still sounded like it sounded different, but it was still like fucked up. And I did a bunch of like, how would you call that? Like, detective work, I guess, and I figured out that the I built it on strip board, and there were like some traces that were very long on the strip board and that I didn't cut, and they apparently like they acted as antennas, and they picked up the oscillations from the other oscillators, the other two, and so it modulated the other oscillators, and so they all like cross modulated basically, and that made it sound terrible. And so I just like shortened the traces, and that actually made it much better, and it worked. So
that's wild. Yeah. Cool.
But yeah, so now my oscillation is fine. Thank you for that tip. So yeah, it's not fucked up anymore. That's great. But it's still annoying that it constantly beeps. So let me check the rest of the comments, and let me turn on my power supply. Ed says you need 4 transistors and 4 op-amps for this to work. I don't see how that would fix it. I don't just want to add more transistors. Maybe you mean something else. Okay.
How about to make it completely zero out?
Yeah. Someone mentioned, Jay Schnabel mentioned you're missing your second diode. That's very true. Oh, but in my case, I actually don't need it because if I push the button, I make the connection, so I charge up the cap. If I let go of the button, the cap cannot discharge, into the button because the button is just like breaking connection. So that's fine. Someone said he clicked this video, or they clicked this video, thinking it was about reverse engineering malware. All right.
That's what my channel is all about. So I get the malware. I get the confusion.
Yes. Someone asked what the bias resistor is. I am sticking to the schematic. I'm using a 470K, so that should be okay, I think. And also, I just tried removing it because I thought maybe if I remove the bias resistor, then it doesn't have the bleed, but it does have the bleed. So that doesn't seem to be it. What else?
Why don't we do the famous Moritz VCA instead?
Which one is that?
You have like I don't know. You have a VCA video.
That's true. Oh wait, yeah, someone mentioned that we might just want to add in like a drain resistor for the cap, so that it doesn't rely on like discharging
yeah, that's smart.
through the transistor. Let's try that. Well, yeah, but my VCA is like more involved. You know, it's like 2 transistors, and then there's like 2 op amps in there, and all kinds of shit. It also would sound different, I think. Yeah, okay. Added the drain resistor. Let's see. Yeah. Well,
where's my tobacco?
It's still like draining like very slowly, and it doesn't go to 0. I wonder if that might be like. I wonder if, you know, because in the schematic, like if we jump back to that, we can see that they actually.
I have an idea also, if I can just input that if you want to. It's to have a lower voltage on the 4106 and higher voltage on the VCA.
A lower voltage on the, what do you mean?
On the 4106. Because you're doing 12 volts on the 4106, so it's very hot.
Yeah, so my thought was, I mean, they use 5 volts here, right? But they still like aggressively cut this down here. Like it's crazy. It's like 33K to 2.2K. I think I can just like do one up them and say I'm going to use 33K and then 1K. That should cut it down to the same levels, and probably the ringing is expected. But since the signal is so hot, as you said, it probably is just very audible. Let's try that.
I need to. Give me a sec, yeah?
Yes. Sure. All right, I'm gonna run the output to the capacitor, and then I'm going to take a.
I still think it would be really fun with a thing like this to trigger it with a piezo.
Sure.
Because you could have like a little box that you just slap that gives you a cowbell sound.
Well, you could just take the piezo. You could just like run into a comparator, like an op-amp comparator.
Yeah.
And then you just feed that into this, and there you go.
But I would want to have some control on the VCA, like the tail.
Yeah, I guess you could, add in the drain resistor and make it a pot. And then, if you decrease the resistance value, it's going to drain quicker, and so that's going to influence the curve. All right, so I did it. There's no ringing anymore. But there's also no sound anymore.
Yeah, it's true. Analog is onto something. We just take a cowbell, and then we glow a piezo to the cowbell. You smart man.
Oh, listen to
cowbell
this.
to trigger cowbell.
It's just making noise now.
Ooh.
What the hell? Oh, okay, I'm stupid. I took the output from the input. I shouldn't have done that. All right. Back to the same stuff. That's a weird VCA.
Yeah. They had faulty transistors, and that's why it worked for them. I am inclined to believe that.
Yeah. Let me check if I did anything different that they didn't do. So yeah, I changed the values of these resistors over here. That's fine, I guess. I did. Otherwise, I think I did what they asked us to do. So we
Yet Terula and want to see the breadboard again.
Oh, sure. So we get the trigger from here. We charge up the cap. They use a, let me check again what they use. They use a 0.47 micro. And then they route it through 100K, which we do too. Oh, listen,
filter it out. That's true. Since you were saying like they go into a filter later, do they maybe filter it out later? Herman, that is the point.
Well, I think the filter that they have is a bandpass filter. And it would still like pass the ringing through, I guess.
But if we skip the VCA part and we just do the 2 oscillators into a bandpass filter, sounds like a glorious experiment.
That's true. But do you notice that the ringing has disappeared?
It's because of the pen thingy.
I think you were maybe onto something with the... Wait, also if I move, it changes the ringing. You hear that?
Oh, you turned it into a radio.
Maybe. This is really strange. I mean, also if I remove the cap, like it's still ringing. So it's not that the cap is still charged and it's like still allowing it to sound. So maybe, I'm thinking maybe it's also just the breadboard. You know how breadboards are noisy and oftentimes you will like get the signal.
Yeah, like if you do the capacitor to ground, if you switch that one to a polarized, then maybe if there is sound in the ground lane or whatever, that won't push through.
Oh.
I mean, it's super off. But I'm thinking that, I don't know what you went with. The one I went with, the 330 NF.
Well, this is a 15 actually. It's super small.
Oh, that's really small.
Yeah. So what's interesting also is that at the collector we have the full oscillation.
Yeah, I noticed that also.
And then after the diode we have like a kind of lower version of it. Is it maybe... I'm thinking maybe the...
Yeah, try like a 1 M, like a mega resistor, like Sean Porio is saying. Just pull it down, keep it open. Or different diodes. Yeah, but the diode, do you think diodes maybe? I don't know. You could replace the diodes for like, I don't know, like capacitor instead. So just have... There's so many things you could try.
Yeah.
And they would not solve anything.
Well, I mean, like they said, like if we increase the resistor size here, it should do something. But what I tried earlier was like I did just like take out the resistor entirely. This guy. And that does seem to be making it a little bit quieter, but it's still there. Like I also thought that maybe like, oh, Simon disappeared. Interesting. So I'm just gonna go on alone. So I assumed that if the resistor is gone, then we don't bias the transistor anymore, right? And that would mean that the sound should go away because, well, realistically, it shouldn't be turning on and off right now. But I think it still is turning on and off, basically. But yeah, if I do put it in, it's getting louder, the ringing. So there seems to be an effect there, definitely. Well, now I'm curious about the...
Just had a bit of a dip in the internet, sorry.
Oh, you're back.
Yeah, it just, I don't know what it did. Dipped out.
That's cool. Bad. So yeah, what I just tried again was like taking out the biasing resistor here, and it does make it quieter. So
I think it's curious with, if I'm reading the schematic correctly, like is it the C22 is like reversed in my opinion.
Oh, you mean this one?
Right underneath Q50, C32. Yeah.
Well, yeah, it's a bit strange because they use the polarized one and then they have the negative side to the left, right? So
exactly.
Positive side
like it
here, but
the signal goes in on the negative side and out on the positive side.
Well, it's swinging above and below 0 volts, right? So, but yeah, the strange thing is that we saw that the voltage here goes negative, right?
Yeah.
Oh yeah, but because the Schmidt trigger is 5 volts. Oh, probably for them it doesn't go negative because no, it does go negative.
Yeah, because I was on 5 volt and it was stuck on negative.
I think it's always going to go negative. But that also doesn't help us with the ringing problem. Well.
Reverse engineering a 5-component VCA that doesn't work.
Yes, that's true. Well, I really wonder, like, if they did anything differently. But we like in spirit, we do the same thing. So we get the oscillation, that's fine, that works. We divide it down, that also works. We feed it into this fake ass VCA. And then we have the 100K here that goes to the envelope.
It kind of works, yeah.
It does
in chat, work. They're saying we could call it the kinda cowbell.
Well, I mean, if you want to call this a cowbell.
It's the kinda. Actually, it ties very well into my... I'm going to plug myself now. I just released an album that is called Kind of a One. So I could release the kind of a cowbell.
That's a good idea. All right, so as Christopher says, it kind of works, right? So we get the idea, like there's just some stuff that's not perfectly perfect, but you know, let's just move on. I feel like it's a bit annoying to just like get hung up on this, right?
I can't. Like I don't even have kind of a VCA. I have a click sound.
But wait, didn't you remake it with the other transistor?
Still doesn't work. It's less than kinda. But I do have 2 oscillators that I can play with a bandpass filter. So I'm happy to do that.
You have 1 more than me, actually. But yeah,
I have an infinite cowbell. Yeah.
Yeah, but if you look at the bandpass filter, right? So it's this beast over here. Boom. Oof. This is really confusing. Like I hate it when like I like it when in the circuit, like a section is like when it's clear what it does, like what its purpose is. And here it's like they, you know, to get the bandpass, like they mix a bunch of resistors and capacitors to like get that effect, right? And well, I guess we can cut it down in a way if we look at, if we isolate like one of the paths, right? Because this is coming from the top oscillator and this is coming from the bottom oscillator. And so we could just say, let's not care about this thing for now. And we could just look at the rest. And this would be like the one kind of, this is just a bandpass. And then you just have like an additional input. But even then it's like, so you've got a cap in series. That means that normally that's like a high pass with a resistance to ground.
Okay, stop for a second. So Fuzzy Music also just built it and has the same result as you. 2-0 here.
Interesting.
Yeah.
Yeah. So maybe that's just like a feature, not a bug, right?
Yeah.
Yeah.
Next episode, you need to tell chat to everyone reverse engineer with you, so we can all have the results in chat as well.
Of course, that would actually be the best outcome of this, I guess. Analog says maybe there's something they didn't mention in the schematic. Yeah, maybe. Like I'm wondering if like maybe further down the road, you know, like further in the schematic, maybe at some point they do something that would
Conspiracy theory.
What?
They released this schematic for everyone to copy, and it's a fake. This is not at all how they've done it.
Maybe. Yeah, they're just misleading us.
Yeah. They're like, ha, everyone is going to try to make the 808.
It's a compelling theory. I like
it.
Okay, but maybe let's look further down the road what they do, right? So they bandpass filter it. We're just going to assume that that's what that is. They have another high pass here for whatever reason. seem to like high passes. And then there is a potentiometer over here, which is a volume control, like we saw that on the panel earlier. And then they have another high pass. And then they buffer the output, and then it goes to the output. Okay, but none of these things would like cure the ringing, I think.
Not
Well,
if it's high pass.
Oh, but look at this. So this volume knob here, you can see that they've reduced maximum volume, right? Because they put a 2K8 here and they put a 5K here. And that means that at the maximum setting of the pot, you don't get the full volume from the output. Like you get about not even half, less than half. So maybe they disguise like the ringing by just making it, by making the maximum volume be quite low in comparison to what comes out of the filter. And then, maybe that masks it. I'm not sure.
But it seems to me like they created a non-functioning VCA and then they tried very hard to solve it for themselves by making 3 filters in a row with a volume pot.
Yeah. Well, what's strange to me is like maybe let's jump back to the simulator, because what's strange to me is that here I think it's looked like as if it's working properly. Wait,
it did.
I need to let me make this much slower. Let me make this guy much smaller too. And I'm going to increase the speed of this thing. Aha. You see that? Oh, but that's in the microvolts. You shouldn't be able to hear that. So
but it looks good.
But it's like swinging between like 200 and 400 microvolts, so that's nothing. So that shouldn't be audible. Maybe I'm going to try just the things that I changed. But yeah, that doesn't look like it does anything. That's so weird. Oh, look, now it triggered. And I'll get the... Oh, it triggers forever. Why? Okay, so the simulator says that it should work.
Like what you could do is, but that's not what you want to do. Like we don't want to add other things than what they have done, because you could use like a MOSFET transistor after the fact on the signal that is triggered by the same button press or whatever that silence the signal completely as soon as the VCA is off, if you get what I mean. Because that just acts as a kind of a switch that grounds the signal. But it's... But it would be pointless.
Well, yeah, it's like fixing a problem that shouldn't be there, right?
Yeah, exactly.
This is a mystery. This is really a mystery.
But I said it. I called it. I called it very early on that the VCA is a scam.
You did, yeah. Okay, here's what we're going to do. So we're already like at the 2-hour mark.
We restart. Yes, I agree. Let's start from the beginning.
No, what we're going to do is like until next time, which Simon, I hope you want to come back. Like, I would love to just like until then look at this thing and try to figure out like what's going wrong. I would love to continue like to get the whole thing set up on the breadboard. If you're up for that.
Will it be in 2 weeks or in 1 week?
Well,
or in 3 weeks? In a year?
I guess whenever I figure it out. So since it seems to be kind of like a complex problem, it might take a while. I'm not sure.
But if you want to, if it's like, let's imagine, we say it's next weekend.
Yeah.
Then what could be really fun to have done also on the side of doing this, we each do our own take on our own cowbell, so to speak, based on the same principle.
Yeah.
Because I'm going to do the piezo one.
It sounds great.
We present it.
Yeah.
It's a full-fledged product, and then chat can vote. Win.
I was thinking more on the along the lines of like a school presentation. You do like a PowerPoint.
Yeah, exactly.
Yes.
Ooh, I'm gonna call my dad. He's gonna help me.
That sounds fucking fun.
Yeah.
All right, but yeah, let's do that. Let's shelve this. We're gonna continue this. We're not giving up on the cowbell, never.
No, never.
No. But yeah, I want to also have like a little bit of time, even though I said it's going to be 2 hours. We're already over, but I would love to do a little bit of Q&A because we were ignoring the chat so much. So if you want to ask any questions, ask them now, and we will try to answer them. If there are no questions, well, then we're going to end it early, but let's see. I'm gonna
I want to say, I take no blame in ignoring the chat. It's not our fault. It's the Cowbell's fault that it's been hard to pay attention to the chat.
That's true. Yeah, it was a challenge.
I mean, because you did this before. Oh, wait, I'm gonna switch angle again.
All right.
Primarily to brag about how cool it is when I switch angles.
I only have one angle. Like you one up me there. All right, so there's one thing here. Superstring Spacecraft says, is there a chance if the DC offset present on the input you are using to listen, like microphone parasite power or something similar? Huh. Could be, but if I get you correctly, then that would be outside of the circuit, right? But it's like we hear the oscillation from the actual circuit, it's like the actual frequency. So maybe it's bleeding into the output somehow differently. Maybe that's what you mean. It could be something to look out for, yeah. Christopher says it could even be Miller capacitance or something. I don't know what that is. I'm going to look that up. Maybe you could explain? Simon, are you still there? I don't hear you. Something happened.
Is it only that one that works?
Now I hear you. All right, what else? Someone asked, can you let the original cowbell hear? Kind of curious what we're aiming for. Didn't catch all of the stream. Actually, we try to sound it like in the browser, like there's like a demo on Wikipedia, but chat couldn't hear it, so I'm sorry about that. You would have to look it up yourself. Maybe next time when I prepare for this one, I'm going to bring, like I have a TR-8. It has like the cowbell sound. We're going to listen to that. Herman asks, are BC 547 and 550 basically the same? Yeah, I have to Google that. I only know that the 547, 548 are basically the same, but the 550, I'm not sure. Analog posted a comment from Sean saying, still believe it's possible that the transistor beta difference might need further rebalancing of the resistors to get the right biasing. So you're referencing the emitter resistor and then the one at the base, I'm guessing. Yeah, that could be true. Something I will try out.
Would be nice with some newbie questions that I could answer.
So Ian says the circuit will distort if the input signal is greater than 1.5 volts peak to peak, which is approximately the base to emitter saturation voltage of small signal transistors. Well, distorting, I think, is not our problem, right? Like,
no, that would probably just be cool.
Probably, yeah. Kim Jong-un said, very cool, mate. I'm happy that the glorious leader likes the stream.
A personal friend of mine.
All right. Christopher says, within the transistor, there would be parasitic capacitance that can hold a charge. Interesting. Maybe that's it. I don't know. Superstring says, it will ring if the input supplies the cowbell output with some DC.
Can't everyone have a blue check mark now?
Who has a blue check mark?
With Twitter blue.
you talking
Sorry,
about?
I'm taking care of the important questions.
Oh, about Kim Jong-un. Okay. Joshua says, is there any ADSR from the trigger? Like, does it control the VCA, telling it to get louder than to stop? No idea how the trigger works. The trigger that they have, I can quickly switch over to that. So the trigger
Yeah, that's what's so weird with this VCA. You just ping it, and then it supposedly does a thing.
Yes. Yeah, I mean, that's what they do. Like, they always use this setup here. That's what they always use to buffer their triggers. And the way that I understand it is basically you get up here, you get your already preconditioned trigger from the CPU, basically. And then that gets fed into this array of resistors. And all it does is like it activates this transistor, which allows current to flow in this direction, which then allows current to flow in this direction. So all it does is like it just opens this transistor, and that has current flowing in this direction that fills up this cap. And then this cap just like discharges into these VCAs. That's all it does. And that's the same thing that we do. If I'm not completely mistaken. Like they also have like this weird thing over here, which is a bit strange. Like they allow like this cap to discharge into this cap, and then that cap discharges again into this direction. Thinking about that
basically creating some sort of weird envelope.
Yeah, I was going to say, I think this is like a kind of delayed,
yeah.
This is going to delay the tail, basically. But
how do they do, like, what VCA do they have for like the kick drum and stuff? Like, because you can control decay on some sounds.
You don't need VCA for those.
Oh, okay. They do that, whatever it's called. It's called something.
They use the bridged T network, which is it's like an oscillator that you like you excite it, and then it just like swings for a little while and then it dies down. So you don't need.
But how about for clamp and snare and?
They use this VCA. This.
Oh, they do.
Yeah,
okay.
Yeah. Wait, the symbol is over here. Yeah, this is the same.
You know what I'm gonna do? I'm gonna go to my electronics store and I'm gonna buy every transistor they have. Just try it with all of them.
Yeah.
One at a time.
All right. Sounds like
See
a plan.
what happens.
Cool. There are more questions from Analog. Why do they do the double transistor thing for the trigger? I'm not sure if you could make it happen with a single transistor, because if you use a NPN, you always invert the signal, right? So if you take if you just take a gate from here, you feed it into this transistor, then it makes the voltage here drop, right? So the initial state is that the voltage here will be high, the trigger comes in and it makes it drop. So it's inverted. It's from high to low. And then they use the PNP over here to invert that again, to make it like from a from a high level the high level drops to a low level, and that makes like a current flow in this direction. So that's why I think they use that. I'm not sure, there might be more reasons, maybe something about the sound, I'm not sure, but I don't think so.
Someone said isn't it dual transistor thing somewhat similar to the gate to trigger circuit?
Gate to trigger circuit?
I've only seen one gate to trigger circuit when I looked that up.
No, it's actually not. It's actually not, because if you as long as you give this a high level voltage here, like this transistor, as long as the voltage here is high, there will be current flowing here. So it's not like if there's a long gate coming in, you get a long stream of current, if you will. So I'm 98% sure that just like their computer thing produces the trigger, and then this just buffers it, basically.
I'm gonna do all my gate to trigger with analog weapon and a microcontroller instead of the schematics I've seen online.
Right? Why?
Because it's so easy with a microcontroller. I'm assuming.
I mean, I prefer to use just a comparator. Like you can just use a high pass, and then you feed that into a comparator, and then you have like a nice little trigger, basically.
Mm-hmm.
All right.
I can try that.
RDM says, thoroughly enjoyed this, gentlemen. Got to go, but really look forward for the next installment at all the very best.
Yeah, wait. When he said that.
Oh, you did wave.
So you know.
That's nice.
Yeah, I wave.
That's nice. Okay.
Like a queen.
Like a regal wave. That's nice.
Yeah.
Okay, I think we can leave it here because we're way over the time limit. Simon.
So what are our promises for next time? Just to reiterate our promises. So for next time, we have solved everything and we have made our own thing also. And
so at the very least, what I want to do is like I want to go back and look at the VCA and figure out why for us it keeps ringing, right? So that's the absolute minimum. And then also what would be cool is if we had kind of the oscillator set up and tuned to the actual frequencies that we need, right? So that we are true to the sound, whatever. And then, you know, have both of these set up, have both VCAs set up, and then if you want to be like a model student, you can also just already set up the bandpass. And then that's it, right? That's the cowbell. If you want, sure, like go ahead with the piezo thing on the trigger. That would be cool.
Yeah, I think if you do all of the things you said now,
yeah,
that I can do other things. Why should we do the same things?
That's true.
I wonder.
Sure.
Well, I think you should make an entire video at some point, like fixing the 808 VCA or something, if you're able to solve it.
Yeah. Actually, next one's going to be about a kick drum.
Okay. With the twin T thingy?
The bridge T one, yeah.
Yeah.
Yes.
I don't know where twin came from. That's another thing.
It's like a different topology. Like you can also do it with the twin T network.
Yeah.
But yeah, that's it. Like, okay, Simon, thanks a lot for coming on. I think this was super fun. Even though we didn't get to the end and we didn't get the whole thing set up, I think we made some good progress. It's fun to talk about how shitty this VCA is. Hopefully we can figure it out. And I will see you next time. And also for everyone still here, I highly recommend that you check out Simon's podcast. It's great fun. There's a bunch of episodes with
we can make a playlist with all the episodes you're on.
Yes, which are quite a few already. Yes. So yeah, if you're interested in just hearing us ramble for like 2-3 hours, then tune in there.
Only talking about Succession, but spread out through a couple of seasons.
Yes. Did we spoiler it?
I doubt that. Did you see the latest episode though?
I saw the first one of the 4th season now.
Okay, so you haven't seen more?
No.
Oh, you're in for it. I got surprised. I didn't think it was real. What happens in episode 3, I think, or something. So you're in for a ride. There will be no cowbell next time. We will only talk about Succession.
All right, I look forward to that. Cool, but then I'm going to end the stream now.
It's been lovely. Thank you for having me.
Yes, thank you so much for coming on. And I'll see you next time.
Yeah.
All right. Bye, everybody.